The second video for this week is a quick transition from a standard linear model where all the effects are additive to adding a little bit more complicated twist to our model where we have linear interaction effects. So what does that mean? Well, if we go back up here to our last model that we ran, this was certainly the most complicated model that we've run, where we have y is our dependent variable, and then we have x1, x2, x3, and x4 as predictors. But if you notice that each one of them just has an additive sign, and that plus sign is a logical OR. So that means that y as a dependent variable can be predicted by x1 or x2 or x3 or x4. But what happens when we talk about interactions is interactions are a logical and. And in R, we have a shortcut operator. It's an expansion operator, and that's an asterisk. So in most languages, you would expect the asterisk to be a multiplication, and in fact, it is a multiplication operator unless it's used in a formula. So now I have y tilde x1 asterisk x2, and what does that mean? Well, now it means I'm going to just run this code right away and then go down here. Let's see, I need to go all the way down to the bottom. And what does this mean? Well, the asterisk is an expansion operator, so what it does is it tests the main effects first, and then it expands to however many predictors you have. So I have x1 and x2, and then it has x1 colon x2, which is the interaction. And the interaction says that x1 is a predictor and x2 is a predictor. Well, what happens if I take two of those variables and multiply them by one another? What I will get is a prediction of y with x1 times x2. But it has a slightly different interpretation than if I created, I'm going to create a new variable, let's see if I can do this, x1, x2, and I'm going to multiply them. Now notice that this truly is a multiplication. And then what I'm going to do is I'm going to say lm24.oa, and maybe I'll just copy and paste. How about that? I'm going to copy and paste that, and instead of doing x1 star x2, I'm going to do x1 x2 like that, and then I'm going to do a summary of lm24. So let's see, I don't know, I can't remember if I did that. Yep, okay, so I did that, and now I'm going to run both of these, and what do I get? I have a summary. So let's compare. What do we have? I have x1, x2. Now instead of having that colon x1 colon x2, now instead I have x1 times x2, which is explicit. So maybe what we can do is we can do a comparison. I'm going to do a summary of lm24 just so that I can have them close by. So here I've got minus 0.02847. I have here minus 0.02847. Same thing, right? And then here I have, this is by brute force, I've multiplied this. I got 0.02439, and here I've got 0.02439. Not much of a difference, right? And there isn't much of a difference, at least not in terms of any of these parameters. There will be some subtle differences later on, but you can see that the multiplication of x1 and x2 is identical to the interaction, and it is a logical and it means that I want to know whether x1 is a predictor alone of y and x2 is a predictor alone of y, and then I want to know if x1 and x2 together help predict y above and beyond x1 and x2. And I've just shown you in brute force fashion that that's a very simplistic way of looking at the interaction term. And we can have linear interaction effects. That means that we have two predictors that have a rectilinear relationship, a straight line relationship with the dependent variable y. And in the next video, we're going to talk a little bit about what happens when you have non-rectilinear or non-straight line relationships with our dependent variable. So stay tuned for that.